Hello, Math 20-3, and welcome back. So we're going to finish off 1.3 now. So let's keep going. So it says, Reg timed himself jogging on a race course. He passed the 300-meter point 1.5 minutes after starting, and the 600-meter point 2.8 minutes, or after 2.8 minutes. Show this on the graph. So here's the solution. So we're kind of just showing that, well, the graph would start from 0, 0 to begin with, right? Because at time 0, he would have gone 0 meters, right? So it would go from there. And then it would also pass through point 1.5, so that's, right there. And then he's at 300, so that's that one. And then 2.8, we just kind of had to approximate where 2.8 was, and that would be at 600. So moving on to the next one here. So now it says the rate of change is equal to the slope of the graph. So let's just go back a minute to figure out what we mean by that. So the slope of the graph, all you need to do on these ones is draw a triangle. And actually, you could have drawn a triangle. You could do two things. You could draw a triangle from there to there. Oh, not that far. From there to there. And figured out your rise and your run. Or you could have done the whole triangle. You could have went right from the top all the way to the bottom, and then from there to there. And that also would have been right. You would have been at a rise and a run. You could do either. Slope's going to be the same no matter what you do. But let's say that we chose this one here. So from there, oh, I went too far again. So from there and then up. And we wanted to figure out what those were. Well, the bottom part here, if I want to figure that out, well, this spot right here, right, that was 2.8. So, and then this spot right here, that was 1.5. So even write that, 2.8, and then this spot was 1.5. So if I want to know what the distance between those things was, I would just go 2.8 minus 1.5, and that would give me my run. Okay, so we go 2.8 minus 1.5, so 1.3. So that's going to be a run of 1.3. Okay, so I got that part figured out. Now let's figure out what my rise would be. So that's going to be, well, the top here is at 600. The bottom was at 300. So if you go 600 minus 300, my rise would be 300. So if I was going to figure out my slope, it would just be, so slope is equal to rise over run. So slope is equal to, my rise is 300, my run is 1.3. So then that would really just be my answer right there. And I just want to kind of show you on the next page here. They kind of made a mistake on this, actually. I don't know why they did this, because we've got 300 over 1.3, and that's what I had. But then they said 300 over 13. That doesn't make any sense. This is actually a mistake. So the answer should have just been this. You could have put that in your calculator too, which would be equal to 231 is what the answer would have been. 231 meters per minute. All right, so I'll let you guys kind of look through that. Let's get to ones where we're actually doing it here. Okay, looking at number 7 here. It says Maria is filling a rectangular swimming pool with water. She knows that the pool will hold 13,500 gallons of water. After 45 minutes, she estimates that there are approximately 2,250 gallons of water in the pool. All right, so at what rate was the pool being filled? So for right now, we're just going to ignore this number. We don't really need that yet. So just ignore that. We're going to look at this number and this one. And I've just kind of set up a graph here to kind of show you where we're going to get this from. So on the left side, I've got volume of water, right? So we'll call that V, and that'll be measured in gallons. And then the bottom, I've got that measured in minutes. So time in minutes. So T in minutes. Okay. So now at time 0, right here, the volume is also going to be 0. So we have a point that's going to start right there, right? The next point that we're going to have at 45 minutes, so that's right there, right? Between 30 and 60 minutes. It says that there's going to be 2,250. So that would look something like this anyway, right? Like a point up about there. So now if we draw a straight line from there to, oh, come on, straight. Anyway, maybe I can move it now. Anyway, you get the idea. It's hard to make it like line up with that point. So if we got that straight line going up like that, that slope there, that is going to be our rate. That's what we want to find, right? So all that's really going to be is I know that this point, the rise of this point going up to this to here, let's make it just like that. I know what that rise is going to be. That's going to be 2,250. And I know my run, this part, is going to be 45 minutes. So if I want to figure out what my rate is, that's just going to be rise over run. So my rate is going to be 2,250 gallons over 45 minutes. And you can see that we didn't really need to make this graph at all, because all I could have done at the beginning is just go, that many gallons over that many minutes is going to give me an answer of gallons per minute. So if I just divide those things, so go 2,250 divided by 45, so 50. So there's going to be 50 gallons per minute. That's how many gallons we're going to fill every minute. Okay, now the next part says, how long will it take to fill the pool at this rate? Well, it'd be really hard to just like extrapolate this graph. Well, extrapolate just means to like make the line extend, like keep on extending upward and kind of figure out where it'll end up. Because we're only at 2,000, we need to go up to 13,000. That's going to be way off our graph. But what we can do is make an equation, make an expression. So what I'm going to say is V, right, this side of the graph, is equal to, and it's equal to our rate. It's equal to 50 times t. That's what our line does. That's the equation of our line. So at any point t, we can just multiply it by 50 and get how much volume we have. Right? So our rate is always just the number out front of t. Right? I'm saying right too much probably. Okay. But now this says how long will it take to fill the pool or at this rate. So all we need to do now is to fill the pool, we're going to replace V with how much the pool would be filled. And that's going to be 13,500 gallons. So 13,500 is equal to 50 times t. And we're looking for t. So now just a little bit of algebra. All we got to do is right now we are multiplying both sides by 50. We always do the opposite. So we're going to divide both sides by 50. So divide that side by 50, divide that side by 50, and we get t is equal to 13,500 divided by 50. So 270 minutes. So you'd say t is equal to 270 minutes. And then circle your answer. Okay, moving on to the next one. It says Tom is a long-haul truck driver. On the first leg of his current trip, he traveled 380 kilometers in 5 hours. If he drove at a constant speed, what is his rate of travel? So we could make another table like we did before, but like I told you last time we could have just went 2,250 gallons and divided by 45 minutes. Let's do something similar. If we can just go through rate, which is your slope, right? Is just going to be equal to 380 kilometers divided by 5 hours. That's going to give you a rate of kilometers per 1 hour if you divide those. So 380 divided by 5, so 76. So our rate is 76 kilometers per hour. And actually, probably for the sake of time, I'm going to let you guys skip B. It's kind of a long one. Okay, so let's move on to 9. So Miriam is reading a book at a rate of 0.6 pages per minute. How long will it take her to read the entire 321-page book? All right, so first thing we need to recognize is that this 0.6 pages per minute, that's a rate. Right? So now we just need to kind of set up our our formula properly here. So we want to, what we're going to have is pages is equal to, and then the next two here, it's going to be rate times time, right? So our rate we have, so it's going to be 0.6 times time in minutes. So that's kind of our just general equation there now, right? So it says, how long will it take her to read the entire 321-page book? Well, all we need to do is replace number of pages with 321 and then solve for t. So let's do that over here. I'll just rewrite this, but I'll write it as 321 instead of p is equal to 0.6 and then multiply that by t. So then the next thing I'm going to do is just divide both sides by 0.6. Divide that by 0.6. And we are left with t is equal to 321 divided by 0.6. So 535. And it's in minutes. That's supposed to say min. Okay. After 2 hours, how many pages will she have read? Okay, so let's just start off with our formula again. P is equal to 0.6 times t. And one might think, well, 2 hours, that's time. I'll just throw time in there. The only kind of problem is, if you look back to here, to our rate that we were using, it was in pages per minute, not pages per hour, pages per minute. So this formula that we're using right now only really works if time is in minutes. So that's not too bad. All you got to do is just convert 2 hours into minutes. So how many minutes are in an hour? Well, 60, right? There's 60 minutes in an hour. So this would be 120 minutes. So then all you got to do is finish writing this out. P is equal to 0.6 times 120 minutes. So P is equal to 0.6 times 120, 72. So 72 pages. Okay, now says the line of the graph has these points. So if you wanted to, you could just kind of sketch it out to make it look right. Or you could use your formula, m is equal to y2 minus y1 over x2 minus x1. You could use that. Or you could just kind of sketch it out and see what you're dealing with. So it says that the first point here is at 0, 0. And then up here it's going to be at 4, 204. So then if you drew your triangle, you'd have a rise and you'd have a run. Well, I can see from here that my run, that's my x value, right? So that's going to be 4. My rise is going to be 204 because it goes up 204. So if I wanted to figure out what my slope was, it's just 204 divided by 4, right? Slope is equal to rise over run. So this one's just going to be 51. Okay, I will let you guys go ahead and do these ones on your own to see if you get the right answer. So moving on. Okay, number 2 says draw a solid line on the graph that passes through point 0, 0. So I'm going to make that point right now because I know it needs to go through there. And has a slope of 5 over 4. So all you need to do here is just recognize that the top, that's the rise. The bottom, that's the run. So just do that from here. Start at that point, and I'm going to go up 5. So 1, 2, 3, 4, 5. And I'm going to go over 4. 1, 2, 3, 4. So if I had a point there, then I would have the proper slope, right? So you can just draw a line connecting those. Okay, now it says draw a dotted line on the graph that passes through the point 2, 1 and has a slope of 2 over 3. So first thing, we just need to plot that. So 2, 1, that's at 2 and then up 1. So that's that point right there, right? And has a slope of 2 over 3. So again, that's my rise. That's my run. So it needs to have a rise of 2. So I'm just going to go up 1, 2. And I'm going to go to the right 1, 2, 3. And that's it. Just connect your dots. And it would also go through your dots. So it would keep on going that way. So one long line that would do that. Okay, so 3 says Henrik earns $73.20 in 6 hours at his weekend job. Xavier earns $55.50 in 5 hours. So calculate their earnings for 5 different lengths of time. So all you gotta do is figure out, well, first rate. We gotta figure out what his rate is and what his rate is. So to figure out that rate, divide them. So I want to figure out how many there are in 1 hour. So let's go 73. Here I'll go rate is equal to $73.20 over 6 hours. So 12.2. So $12.2 per hour is what Henrik was making. Dollars per hour. Xavier, just 55.50 divided by 5, and that will give you the rate for him. Then what you're going to do, I'm just going to show you Henrik here, because I don't need to do both here, I don't think. So Henrik, now that we know that rate of $12.2 per hour, we can make a formula of that. So we can call it like earnings. So E is equal to, and it's just rate times time. So 12.2 or 12.20 for $12.20 times time. And now it just says for 5 different times. You could throw whatever time you liked into there and you would get a different earning. So just to give you a test here, what would it be if that was 3? So your earnings would be 12.20 times 3. So that would be $36.60. Okay, on the same graph, draw a solid line indicating Hendrik's earnings and a dotted line showing Xavier's earnings. All right, so all you got to do is we've got a bunch, you should have a bunch of points now. So all you would do is have time on the bottom, have your earnings up the top, and then we're going to have 2 lines, right? One going like this, one going like that. They're just going to be different rates of earnings. So your time, probably go up by hours. So we'd have like, 1 hour, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then your earnings would probably go up by, I don't know, probably up by like, that'd be 50, 100, 200, 150, I mean. 200, 250, and 300. That probably work. Okay, and then just we need to plot a few points. So I know my first point for Henrik would be at 0, 0, right? If you've worked 0 hours, you'd have earnings of $0. We said that after 3 hours, the 3 we put in there, we made $36.60. So I'm going to go over to 3 and go up to about there, right? I probably made my graph go up by too much. Okay. So, yeah, so that's kind of what you would get for that one. And then let's say we put in 5 for that. So after 5, so 5 hours, so 5 times 12.20 be 61. So at 5 hours, you go up to, would that be about there? Sure. Okay, and then what you're going to do, that should be more straight than that, is connect your lines after that, once you get like a bunch of dots. Okay, and you should have 2 different lines, so one for Hendrik and one for Xavier. So I'll let you guys finish the rest there. So who makes more after an 8-hour shift? You should be able to see that quite clearly on your guys' graphs once you get those done. And calculate Henrik and Xavier's rate of earning. We kind of already did that at the beginning. All right. So Janice is a real estate agent. When she makes a sale, she earns a commission of 4% on the value of the house. She earns $7,560 on the sale of a house. What was the selling price? Okay, so we have to set up an expression again. So what this would be is how much she earned is equal to the rate, which is going to be the percentage, times the cost of the house. I'll call that C. So if this was the cost of the house, we multiply that by the percentage, and that would give us the earnings. So let's just kind of fill in what we know here now. So it says we know how much she earned already. We know that she earned $7,560. Just going to leave the zeros on the end off there. That's going to be equal to, now one might think I might just put in 4%, but I don't. It needs to be written as a decimal. So I'm going to write this as, one might also think that you go 0.04. That wouldn't be it either, because we make interest on top of what we make there. So it's going to have to be 1.04, because 1 times the cost of the house would just be exactly the cost of the house, right? But 1.04 is going to be the cost of the house plus 0.04. So that's that 4% is what it's going to be, right? So that's why it's got to be 1.04. So that times the cost of the house, C. So now all we got to do is divide both sides by 1.04. Divide by 1.04. And we get, so those cancel. So we get C is equal to $7,269.23 would be the cost of the house. Hopefully that one made sense. I know that like 1 there for the rate was probably a little bit confusing. Okay, now we are actually going to cancel the rest of these questions. So you can cancel that one, and that one. We'll skip them. There's just a lot more of the same thing, and I don't think we need to do them. Then what we're going to do is the chapter test. The next one we're going to do is, really it's going to be me going through the chapter test. You're going to do it on Edpuzzle again. But the answers, you're going to do your answers right in the Edpuzzle. So that's going to be how that's going to work. So hopefully that made sense. So that's going to be it for that video.